This is a simple universal joint that can be found in many different applications. You'll notice that it's able to operate over a wide range of angular misalignment and uses an interconnected slotted segment to transmit the rotational energy. The design is fairly simple and can be rather robust depending upon the materials and design choice. Here is the final result. Everything here is 3D printed. When we turn it by hand, it runs fairly smoothly for what it is. The friction you can see here is coming from a larger shaft diameter interacting with the frame. This was a design choice to increase the precision at the expense of frictional losses. Running it by drill, you can see that it runs very smoothly, even as we move it across its range of angular misalignment. It runs very well. This is not a constant velocity connection, and it's difficult for me to show you this here, but it would not be considered a CV joint. So is this a practical 3D print? Absolutely, it works really well, and I would be excited to try it out in a more strenuous application next time. I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out if you're interested.